Applications of atmospheric pressure. The diagram shows a person drinking with the help of a straw. When air is sucked out from a drinking straw, the air pressure inside becomes lower. The higher atmospheric pressure, acting on the surface of the drink, pushes the drink into the drinking straw, and enables it to be sucked into the mouth. A syringe consists of a tight-fitting piston which moves in a cylinder, with the nozzle at one end. When the nozzle is dipped into a liquid and the piston pulled up, the pressure below is reduced. The higher atmospheric pressure, acting on the surface of the liquid, pushes the liquid into the cylinder. When the piston is pushed down again, the liquid is ejected. A siphon consists of a rubber tube used to remove liquid from a tank. The rubber tube is filled with liquid, and one end is placed in the liquid-in container. When both ends of the tube are opened, liquid flowing out through Y creates a partial vacuum inside the tube. At point X, the higher atmospheric pressure acting on the surface of the liquid pushes the liquid upwards into the rubber tube. The difference in air pressure produces a continuous flow through the rubber tube as long as the point Y is at a lower level than the liquid level in the tank. A rubber sucker is a rubber cup that can be made to stick onto a smooth wall such as glass or tiled wall. The rubber cup is made airtight by wetting its rim before pressing it against the wall to create a partial vacuum by driving the air out. The higher external atmospheric pressure outside presses down on the sucker and makes it stick firmly to the wall. A vacuum cleaner operates by applying atmospheric pressure to remove dust particles. When it is switched on, a fan sucks out a stream of air from the space X to create a partial vacuum. The higher atmospheric pressure outside pushes the air and dust particles into the space X. The dust particles are trapped in a dust bag at X, while the fast-moving air is allowed to flow out from the back of the vacuum cleaner. The lift pump is usually used to draw out liquids, such as kerosene from a tall tin or a tank. It consists of a barrel which has tight-fitting piston, with a side tube near the top to act as a spout. There are two valves, A, fixed on the piston, and B, fixed at the bottom of the barrel. Both these valves open upwards. When the piston is pushed downwards, the valve B closes, and the valve A opens to allow air to move out through the piston. During the upstroke, A closes and the pressure inside the barrel is reduced due to the increase in volume of the air inside it. This causes the liquid to be pushed into the barrel by the atmospheric pressure acting on the liquid surface. On subsequent strokes, the liquid completely replaces the air in the barrel. After a few such strokes, the liquid will flow out of the spout. Thank you for taking time to watch this.